Hello, and welcome to EyeOpener, powered by Siemens. On today's episode, I'm delighted to welcome Dr. Natalie Kurgan at Siemens, where we are going to be discussing the topic around data cleansing and the preparation for PdM. So big welcome to Natalie. If you could start off by introducing yourself, that would be great.
So, hi, my name is Natalie. I've been working with Sensei Predictive Maintenance for almost 3 years now, and in my role, I deliver the product to the customer. So we work hand in hand with the customer from the moment the purchase order is signed until they're really operating in steady state, and I pass the account off to a customer success manager.
Perfect. Well, thank you so much for joining me on today's episode. And I guess, let's get straight into this topic around data cleansing and preparation of PdM. So, Natalie, the first question I have for you is just around what are the key steps which need to be taken when it comes to data and PdM?
So this is one of the more complicated topics that customers and even people in my role who are just getting started, it's really hard to wrap your head around because there's a lot that goes into it. So in order to make the best use of PdM, data needs to be a condition indicator and it needs to be in steady state. And sometimes we have to do work on the data in order to fit it into those two parameters. So some of the things that we might do are data aggregation, data transformation, and data cleansing. And sometimes we even need to provide context for that data.
Okay. And I know you touched on a key word, so condition indicator. What does that actually mean?
Yeah, so I guess one of the sort of misconceptions about PdM is that oftentimes we have folks that don't quite understand the AI and machine learning behind it, and they think they can feed it anything they want, and it's going to just come up with these magical, insights into the data, into the machine, and it's not really how it works, though, is it? So the whole point of PdM and the way that we're doing it is to do it at scale. So you can do condition monitoring where you have somebody looking at data and identifying, oh, there's something unusual going on with this asset, we need to go work on it. We're just taking away the need for a person to look at every single data stream. So the data we're looking at still needs to be directly related to the condition of the machine. And if it's not directly related, sometimes it's still useful as context to kind of understand the operating conditions of the machine. Okay. So an easy example would be for a motor. Vibration is a pretty good condition indicator. And if the motor is, for instance, has a variable speed, well, then we'll need that speed as context as well. Even though the speed has no relation to the condition of the machine, it's going to have a relation to what the vibration is doing. So if the speed goes up, vibration goes up, but it doesn't mean the machine is failing.
So Natalie, what would happen if that data is not in the condition indication stage? What would happen?
So in the beginning of working with a customer, we have these sessions with them to kind of understand their asset types. So when we say asset, we're really talking about asset type. We're not talking about every individual machine because, again, scale. So what we do is we have these meetings with the customer to understand what the machine is, how it works, and what data tags or measures are available. From there, we have to figure out, now what do we do? So we have to understand, how does the machine fail? And how does it not fail? What does it look like when it's normal? The other key word, aside from condition indicator, is steady state. So we want the data, basically what Sensei PdM is looking for is it's looking for data that is flat when it's normal and everything's going fine. And when it's not normal and it's failing, the data is not flat, it's doing something else, right? So it's just change detection. But we have a lot of instances, think about if you're looking at temperature on a bearing. Well, if you have ambient temperature going up and down throughout the year or throughout the day, that temperature you're reading on a bearing might also be varying. So that's something we could provide as context, or we could even do a data transformation to take the difference in between the two temperatures. And in that case, ideally, you'd be looking at a flat line. So that's perfect for something for Sensei to monitor. The other thing we have to do is understand, the most basic one we do all the time is, are you sending us data when the machine is off? Sometimes it's really hard for a customer to integrate. That's like the hardest part of the process. And so we like to make it simpler on them, is just say, look, if you can't take away the off states before you send it, just send it. But we need a run signal as well. or a motor current or something to know the state of the machine. And then actually inside the app itself, we can create a virtual measure to remove that off state, because if you don't, you're going to be looking at data it's hard to do without a chart, but it's going up and down. So you might have something, let's say vibration again. Let's say it's normally sitting at, 10, whatever units it is. And every so often it drops to 0 because the machine turns off. One of two things is going to happen here. If you leave those zeros in, you might get false positives that your data has changed, and so the system tells you about it. But the other thing that might happen is it'll get totally desensitized to a magnitude change of 10, which for vibration is huge. So basically what that means is it gets used to seeing these magnitude of 10 drops, and then it might see a rise of 2, which might be a huge indicator of degradation, but it's used to seeing a change of 10, so it's not concerned about it. It's too desensitized. So that's one of the main things we'll do, is remove off states. I touched on data transformation a little bit. We might take the difference between two measures to try and get a flat line out of it, or whatever we determine from our engineering standpoint to try and get a steady state. And then the last thing we need is sometimes to provide context. So that would be your speed for your vibration and things like that.
No, that makes sense. And could you touch a little bit more into the data transformation side? How does that work in terms of what that involves?
Yeah, so inside the app we have an interface called Derived Measures. It's basically virtual sensors that we can create. So even if somebody is sending us all process data that by itself might not be a condition indicator, it's just nothing being read on the machine itself. It might be, here's the pressure before the pump, and here's the pressure after the pump, and here's all these independent things that don't seem to have something to do with one another. We might take that into our system, into Derived Measures, and we can calculate, the actual power that the pump is running at. We might be able to calculate the theoretical power, and then using those we can calculate efficiency, and now we have suddenly all these other measures that we can monitor that are condition indicators.
Oh, that makes a lot of sense. And, you touched within the Sensei predictive maintenance app that we have, you touched on the section that we have, which is derived measures. And I guess just for the benefit of our audience, it would be great for you to just talk about what else that involves. So I know you've given a high-level overview of that, but just to get a bit more information around that.
Yeah, so it is an advanced tool. So we don't kind of give everybody access to it automatically, because you can kind of do some damage if you don't know what you're doing. But basically it's a flow editor. So you drag blocks that contain different logic and you kind of connect them, and it flows from left to right. So you have different inputs, you have different logic, like you can sum things together, you can take in vectors and take the last value, you have if blocks, all sorts of things you can do. And then at the end, you connect it to an output. So you can create a brand new measure, and you can do it in bulk. So you can, if you have 1,000 motors and they all have, 10 measures on them, you can remove the off states from all, 10,000 measures with one derived measure. So you can do it in bulk. Usually in the beginning of a project, someone like me will help and create those for the customer. But what we usually see is over time, the customer wants to do it themselves, and they can. There's no reason they can't. It's a bit of a learning curve at the start.
Okay, perfect. So essentially it helps to simplify the process, I guess, because you're able to manage and do it in bulk as opposed to doing it individually. Imagine how long that would take, right?
Oh, yeah, absolutely. And the benefit of having it in the app is that, a lot of people still do it before the data even gets to us. But it's not always easy. It's not easy to know what the data needs. It's not easy to actually do the transformation sometimes. And I can't help them if it's not in Sensei. Yeah. So with it being in the app, they have us that we can back them up.
Okay. And how do you know what the data needs?
That's a tricky one. So we have to look at the data. So sometimes we can get an idea of what it needs just during discussions with the customer if we ask the right questions. Okay. But sometimes the customer doesn't know what the data actually does. They have an idea of what it does, but they might not know all of the influencing factors. By that I mean context. So what process is a particular recipe, if it's like a food sort of manufactured, does a particular recipe influence what the machine is doing? And was that known or not known? So we do our best in the beginning without even seeing the data often. And then once we get it in the system, we can always go back and tweak things. So we watch it very carefully once it starts to come in.
Natalie, my next question is focused around how many measures need to be taken in order for Sensei predictive maintenance to work?
So my answer is it depends, which is a terrible answer. But it does. It completely depends on the data. So we do have some kind of templates that sometimes customers just want to know exactly what data do I need. But our answer is we'll use what you have. And we can even change our definition of what is an asset. So if they're considering one asset to be actually a combination of a motor, a fan, and a gearbox, for us, that's kind of 3 assets. But if they don't have the data to support those 3 assets, then it's 1. Right? So we can kind of change our definition of what is an asset for the customer based on the data that's available. And we can help them do gap analysis as well to figure out, okay, what do you need? For instance, I've got a customer who they were so smart with how they onboarded their machinery that the very first asset they onboarded, it was a water tank. And it was just sitting outside. It's not exactly critical. It's just a tank of water. It's just sitting outside evaporating to the sun. And they had exactly one measure on it, which was the tank level. Is this thing going to take down the whole site if it goes down? No. But they saved someone by just putting one thing into Sensei. They saved someone a trip on their rounds. So they became more efficient instantly just by letting it monitor the tank level and getting an alarm when it's going to approach a certain level. So if we're smart about it, you don't need a whole lot of data to monitor in Sensei to get benefits from it, but you have to have realistic expectations. You can't use just 1 or 2 measures and expect to catch every failure mode. We've had many people come to us and say, look, we've had this failure. Why didn't Sensei catch it? I didn't get an alert. And so we have to go in and look at the data with them and be like, well, look, you have this many measures, and we're looking at it, and the data now looks exactly the same as it did a month ago, 2 months ago. I see no change. There's nothing in the data. And if there's nothing there to indicate that it's in a state of failure, there's nothing for the algorithms to find. They're not going to make something from nothing. So it's good to have realistic expectations, but we will work with what they have.
So I guess, Natalie, one of the questions that I have around this topic is, from a customer perspective, and I guess this whole talk around artificial intelligence, making this assumption that AI can capture when it's going to fail. And you've probably had these encounters with customers where you've had scenarios and we haven't been able to capture the failure in time. So it'd be really interesting to get your views on this whole topic around that and how you feel about that.
Yeah, we just have to be honest with them, don't we? It doesn't work on, it's not just a magical black box we can throw in. I often say it's harsh, but you can't feed it garbage and expect miracles. You have to have a thought about what goes in. The noisier the data that goes in, even if it is a condition indicator, if that data is noisy or really spiky, if the magnitude change in just a normal period is really big, the app might not be able to find slight deviations because it's used to seeing a large band of noise. So we have to have realistic expectations in regards to that, and we have to be able to have the conversation with them of, are you willing to get more sensing on this? Because if you don't, we're not going to be able to catch that failure again the next time it happens. And they're usually, they might not get it right away, but they get it eventually.
Natalie, one of the questions that we frequently get asked from a customer perspective is, when it comes to starting a project, when it comes to the asset templating process, how are their assets put into the app? And, what historical data is required for that process to take place?
Yeah, so whenever data is put into the app, the algorithms automatically start learning. And they just take a minimum of 2 days to learn. So in that regard, we don't require historical data. And that's something that is kind of shocking to a lot of our customers, because we often get the question, how much data do we need? This is verbatim. How much data do we need to train the model? And I always kind of groan internally, because there is no model in the traditional sense that they're thinking of. It is AI and machine learning. I am not going in and designing a specific, parameters for every individual asset or every individual data point. The point is to scale. So we let the AI and machine learning do that. But we can't put guardrails kind of on the algorithms. Some obvious ones are, and we'll discuss these during the asset templating process. I'll ask a customer, say, hey, are you interested if the vibration goes down on this asset, or are you only interested if it's going up? They never say they're interested in it going down. So what we do is we can go into the algorithms, and in bulk, we can basically disable downward detections. So right off the bat, even sometimes like when data has just started coming in, we can kind of decrease an incidence of false positives. Before we've even seen data, we can arrive at those conclusions. But when it comes to training the model, there is no such thing. The model learns automatically. It's not a model in the traditional sense of like data science. So yeah, no historical data needed. Just get it into the app.
Just get it in. Okay. That makes sense. Well, like you said, I think this question is asked a lot, how much data is required for it to work? Yeah. So like you said, it's just, you can't actually put a number on it, because I guess it depends on each different type of, asset and what they're looking to achieve. So I think from a customer perspective, they always have these, maybe assumptions, because they just want it to avoid failures that they have. And I guess when it does come to monitoring your assets, it's a very kind of up and down process, isn't it? So it takes time. I guess putting that data into Senseye predictive maintenance, it takes time to monitor and to understand the algorithms and to see what's going on.
It is. So what's interesting about what you said there is it's not just about the algorithms learning and the app learning and just providing you amazing outputs. It is equally the users learning and engaging. They are not going to get any success with the app if they don't use the thing. They have to get in, they have to provide feedback. They have to start thinking critically, because I don't know their machines. Yeah. I know data, but I don't know how their machines work. So they have to get out there and start thinking, how else can we monitor this? And the people that do that have huge success. But it's the ones that think, okay, well, data's in, that's it. We can just, click a few buttons every now and then, and why aren't we getting great results? Well, you have to use it. You have to work with it.
Perfect. And I guess with this whole process of, let me start that again. So I want to touch into issues that you've had, or examples of scenarios. I'm trying to phrase it in a way where you could maybe touch on a couple of examples with customers.
Yeah. You could ask something about like, what are the recommendations for, okay, let me just stream of consciousness think here. A lot of people, they don't understand when they start a project how many, it's this definition of the word asset. When I say asset, I'm thinking asset type, because I don't care if you have 1 motor or 1,000, it takes me the same effort to configure it in the app. Okay. I'd rather you have 1,000, because I do just the same thing, and now you have so much more value. But a lot of people think, okay, I'm gonna monitor 20 assets, and each one's a different type. Like, oh God, that's a huge amount of effort, and they aren't gonna get much value, because part of the beauty of the app is viewing data together for the same machines. So I don't know how to phrase that into a question. That comes in, that's the reason why we didn't know that machine was in a failure state when it was onboarded, because they just onboarded one of it. We have nothing to compare it against.
Yeah. I'm just trying to think about how to phrase the question. Well, we could touch into what you mentioned before about I just want to phrase it in the correct way. Or maybe something along the lines of, from your experience of monitoring and looking into data, what's one of the biggest issues you've encountered?
Yeah, I can do
Yeah,
that.
yeah. Okay. So from your experience of looking into the data and understanding the data, it would be really interesting to understand what is one of the main issues you've encountered when dealing with that side and actually focusing on the data within the app.
So it's kind of twofold. One of the biggest difficulties is, like I said, when we talk about the asset and the data with the customer beforehand, we're not usually looking at the data when we have that discussion. So when we get it into the app, oftentimes the data is influenced by outside factors that the customer had no idea was actually going on. So we either need to provide more context in order to take away the influence of whatever that factor is and get us a nice steady state signal that the algorithms can look at, or we can use the asset in kind of a group. So every time I say the word asset, I'm really talking about asset type. So we'd much rather see a big group of like assets in the app. So if you want to onboard 1,000 assets, I'd much rather see 1,000 of the same type than 1,000 assets and 40 different types, because the bigger the group you have, the more context you have. So we've seen before customers you might ask, what happens if you onboard an asset and it's already in state of failure? How do we recognize that? Well, the algorithms won't know it's in a state of failure because all they know is what you've told it. So they've learned from, the first 2 days of data, and they continuously learn after that. They don't stop, but that's their starting window. If it's already in a failure state, then they think that's normal for that asset. But if we have a whole fleet of assets that are really meant to be doing the same thing at the same time, one of the first things we like to do when we get data in is look at the assets in the fleet to see if any of them are sitting like maybe at a much different baseline, or if they're much more erratic with their data. And that way we can identify if one's in a state of failure. And in the same way, if they're all process dependent on something else, we can look at them in a group and see if they're all varying in the same way at the same time. And if one isn't, then we know maybe that one's in trouble.
Okay. And how would you define a state of failure?
A state of failure I'd really define more as a degradation. So what Sensei is doing is we're not predicting failures. We're predicting when they need to maintain it, which ideally is before it fails, right? So you might see the data starts to, if it's steady, it might start to increase at a rate. It might not even be increasing at the same slope or the same rate of change. It might start slow and then start creeping up. Sometimes the data gets much noisier, so you'll see big spikes jumping around when usually it was much smaller sort of range and spike. So it really depends on the signal we're looking at, but really it's just change from typical behavior. If we have a good steady state condition indicator, it's going to be ideally flat or following some control parameter or contextual measure. And if it deviates from that, it ought to be in a state of failure.
So Natalie, to summarize this topic around data cleansing and preparation for PdM, what would you say are the 3 key learning takeaways that someone could take from this topic that we've just discussed?
So I would say the first one is that you need to provide predictive maintenance solution like Sensei with steady state condition indicators. And if it's not already like that, we can help make the data in that format. The second takeaway is that if there isn't something in the data to indicate a failure, the algorithms aren't going to find it. So we can work with little data, but the expectation has to be that we might not find everything unless you provide the right condition indicators. And then the last takeaway is that there's a huge benefit to onboarding many of the same asset type. So a whole fleet of assets, because you can gain a lot more insights than if you're just looking at one by itself.
Okay, that's really great to know. I think especially touching on the final takeaway that you mentioned about essentially being able to do it in bulk. That makes it a lot easier, and especially within the Sensei predictive maintenance app, you're able to do that.
Yeah, so I would say if I want to onboard 1 motor or 1,000 motors, For me, it's the same amount of effort. So for the user, it's the same amount of effort, and you'll get so much more value if you have many more than just one.
Yeah, no, that's great. So, Natalie, on our previous episode, James Loach asked a question for our next guest on the show. That question is around when you were growing up, did you imagine yourself to be working in maintenance, and what led you to that?
Okay, so in short, no. I was actually all set to go to school for music, and at the last moment, I decided to go for engineering, and my PhD work was in biomedical engineering, so I was basically doing predictive maintenance on humans. When I decided to leave academia, I wanted to try, my hand in industry, and I found this role, and I thought, that's exactly what I'm doing, and machines might be easier than people. So that's how I'm here.
Amazing. Well, yeah, thank you for answering that question. And I guess, for our next guest on the show, if you could ask them a question, what would it be?
I would say maybe what has been the most unexpected aspect of working with Sensei predictive maintenance.
Thank you so much, Natalie, for joining me on this episode today, discussing the topic around data cleansing and preparation for PdM. It's been really great to have you on this episode.
Thank you. It was a pleasure.
Thank you. A big thank you to our audience for tuning in on today's episode. Please like and subscribe to our channel and stay tuned for the next one in the series. Thank you.